The plank, when they changed it to the plank, I was like, I can do this all day. And the guys around me are falling apart. And like, I can do a plank for a long time. Like, women's center of gravity is different. But when it was knees to elbows, that was hard. I actually dissected about knees to elbows. I think the problem is upper body strength. You do need, like, the first little, you need some biceps for that. So, all right. I'm going to go through this. I do need you to get this because the graphical method will be quizzed. It's like it gives you some intuition. Close your laptops. I'm recording this. Ask questions so that I know that you got it, and I know whatever gap there is on it. And I gave you a picture the other day where I showed you that the feasible region is a rug on the floor, and this thing, if you graph it as a 3D plot, is a plane. So wherever it cuts off, like if it's going up and it cuts off, it's going to be at the corner points that you end up having the maximum. So the whole point of the graphical method is to find the corner points manually and then plug them back into your objective function and pull out which one's the biggest, which one's the smallest. That's the point, right? That's really what you're doing. So if you understand the underlying what's going on, it'll make sense what you're supposed to do. But I broke this up into steps. Just to give you an idea, I write big. So it still took me a page. I don't think I write the biggest. So I'm somewhere in the middle, probably for writing. But it still took me a page just to describe everything. And so all of you that were saying, I just want to get the equations, it takes some time to formulate these. Give yourself that time. We're going to ask for that time for you. I don't want people rushing through this. I want to make sure you've got this right. Because if you don't have this right, you've got the wrong objective function, where are they going to give you partial credit for all the rest of it? How do you find the maxes and mins if you got that wrong? So make sure you got this knocked out of the park now before you even go to Excel. When they have the Excel things that you're going to still have to input things in the right spot. So you still have to do this. This underlies everything. So if anybody's in doubt and doesn't know it, that's fine. It's not one size fits all. Like how I explain it doesn't mean that it fits you perfectly. It's nothing on you. If you didn't understand me, make an appointment for AI. If you're not getting it from me, I'll find someone who's going to explain it to you in a way that you can understand. It's also not a race for first. It's a race for right. So let's make sure that we get this right. And I know that you have that time clock with you, but we'll do our best to advocate on your behalf to make sure you have time to do this thoughtfully so you get this right. It's going to be worse on the instructor side to grade a whole mess and try to figure out partial credit if you don't have this right. So it's in everybody's interest that you have enough time to write this out. Okay, so we're going to do another one of these hopefully today. That's why I'm doing this. Like, this is the thing. You have the objective function, the constraints, lots of constraints, and then you set up the solution. So the first step is to draw and shade the feasible region. There's a lot of things I love about getting a PhD in math. One is that I don't have to take math tests anymore. I hate math tests. I don't like them. I don't like giving them. I don't like taking them. In my upper level classes, we don't have tests. Unfortunately, you have to take it. But if you want to ever stop that, like never take a math test again, get a math PhD because you don't have to do that anymore. Step one, draw the feasible region. Another thing I really love is that I can go to a computer to answer algebra questions for me. And I'm going to do that because I feel like I don't want to do that. I just don't want to. I'm going to do one of them for you. And then you are plebes, and that's one of the awful things. You have to do that by hand, right? Sorry. I did my time. So how do you do that? You have all these inequalities. I've labeled them on the previous page as number 1 through 6. So you take the first one, and you have to solve that inequality, just like you did when you were in grade school. And I think middle school, if you had middle schools, we didn't have middle schools in Montana. We just went straight from elementary to high school. 8th grade was elementary. So you take that, and I went through my directions so that, you know, there's not one way to do things. You can just subtract first, or you can do other things. Like this is, I just put labels on it so you can see what I did. But the point is you get it to look like y equals mx plus b. Did I make a mistake, Helen?
No, I just got a question.
Sure.
So, like, what if you had like a negative 0.20y, you divided it over, would you still flip the sign?
Yes, you would. Yeah. you would flip the sign. So all those things that you remember from elementary school, they still follow. I just hate this kind of algebra because I don't have good attention to detail, as you probably have noticed, and I don't like to, I'll mess something up. So like, when I see 6 things to graph, I see 6 places I can make a mistake. So that's I'm not why I went to a computer, because I don't want to show you like the ugly side of my mathematical career. But you graph it, and then I put my words, because I saw you guys nodding your head, like how do you graph this? The y values that are bigger than this line. So here's the line, here's the y values that are bigger than this line. That's how I think of it. So I have a lot of immunizations against messy algebra. I remember my Algebra 1 teacher, I came back and I told her I got my PhD, and she was looking at me like, okay, there's hope, I guess. Kate?
When you graph that first line, you can pick any of those constraints.
Yeah. I label everything on my work so that I don't lose where I'm at. If I've got 6 things, but actually I have 7, I try to label them so that whoever's reading it can follow what I'm doing. And I myself, if I get lost, can go back. I'm like, I'm done with 1, I'm done with 2, I'm done with 3.
Graph all of them?
Yeah, you have to graph all of them, right? You can see why I say, okay, I'm past this. I'm a colonel in the field of math. I don't want to do it anymore. So I just checked too, because when I plotted on a Desmos, it looked like the same thing. So it was indeed, when I did the algebra, it turned out to be the same thing as number 1. I just want to make sure, because I'm always in doubt of my algebra skills. 1 and 2 are the same thing. Then I went to Desmos, and you go to Desmos to graph any of these. You have a homework assignment, unless it says not to. You can put the inequalities one by one, and it'll shade it by color. And so I could actually see the overlap of all these regions. They make a lot of crazy looking lines, and I just put the inequalities in, and the darkest regions where they all overlap. So this big B that I have here, the darkest region, is the region. That's the feasible region. It doesn't look like the feasible region that we did the first day because it's infinite, like an infinite cone. But there's one corner point. It's right there, and I circled it. It has one corner point. The feasible regions that you're going to see from the baby problems that you have more than one. The first feasible region that I showed you with the drum kits, that had multiple corner points. You have to check them all. You have to find them all. How do you find that point?
Don't you just like plug it in to make sure that's the highest possible values?
Yes, so we're going to do all that. But how do you find that point, that corner point? One more time. But you're supposed to do it by hand, right? So unless you have like the best graphing skills ever, and you can actually pinpoint that point on your graph, I don't. I just sloppily draw these things up. How do you find that point, that corner point? Come on, your algebra teachers are gonna go, what? What's going on here? Louder? System of equations. It's where the points, the 2 lines intersect. So you have to actually look at your graph and go, which one was this? This was number 5, and this was number 1. Those 2 lines intersect at that point. Lovely. Algebra. More algebra. So how do I find that? On page 4, you can see the overlapping regions and the infinite triangle. And there's only one corner point. I circled it. That's where equations 1 and 5. That's another reason you want to label it. Otherwise, you'll get lost with all these lines. So that's, and hold that thought. I don't want to like mess you guys up now. I just want to go through the process. So that was all step 1, just graphing those points and shading the region. And I did 90% of it on a computer. I didn't go into math because I like algebra, like lots of transformation. I don't like that. Like I think that's yucky. But
how long are we gonna have these quizzes? Like 1 question and like.
There's different ways to ask these questions. For example, I could draw a feasible region and ask you, is that the feasible region for this? Right? So then you can say yes, why or why not? And you say, well, one of these lines has the wrong slope, so it can't be the right feasible region. So that's a way to quickly get someone to answer the question. and get what a feasible region is. There's the old-fashioned way, the sledgehammer, actually do it. I'm not a fan, but you could be asked to do it. I don't have that kind of power to make up all the questions, but that's what I would do if I had you in my class alone. I would just say, here's a feasible region. Is this I would actually let you use Desmos. Because you got here, you did your SATs. Hopefully, if you had to one day, if your whole platoon will die because you can't find the intersection of two lines, hopefully at that moment you can do it. But I think we're past that class. There's a machine that will do it for you. Let the machine do it. But I don't have that kind of power. So you might have to do this by hand. I had to set the two equations to each other. I use substitution method. I'm lazy, so I look at it and say, what's going to get me out of be the least amount of work? I thought the least amount of work was substitution method. Remember that? You can do it. Sometimes the addition method is easier. I just looked at it and I found the answers. So I did the substitutions, and that's how I got the X and the Y. So that's that corner point. And then you plug it in. So that was a question Helen, you asked me. I had one corner point, I take the X, the Y, and plug it into the objective function, and I got 100, right? If I had more corner points, I would have to do all of them. And if I'm looking for a minimum, the lowest value is going to be that corner point. That is going to be the answer. And I answered, you still have to answer the question. Again, think rubric. That's not enough. Don't lose your points after getting to this point here. Answer the question. They asked, what combination of calls do you have to make? Well, you have to make 500 daytime calls and 250 evening calls. I always doubt my algebra, so I went and tried another point. I tried 600, 200, which is in the feasible region. I just went to the graph and looked, it's in the feasible region, and I also got 100. So that's not unique. So you asked about, who asked that about, are you guaranteed a point? This was the corner point method going to work. Who asked that? Somebody asked that. Like, if the corner point is going to, yeah, okay, so in the reading, you had these assumptions. Do you remember those assumptions? To use this method, the function has to be linear and all that stuff. They call it proportional assumption. This means that you don't have squares and ratios and things like that in your equations. That has to be followed, and this region that you have has to actually be a boxed-in region. And this is not. So you don't have a unique solution here because of that failure of assumption. But it still worked. It gave me an answer of what combination will meet the constraints and give me a minimum cost. Still answered the question. So it's still, even though that one assumption was not held, this still worked. So this was a bad example, but I already started on it, so I had to finish it. So a good example would be the Zildjian drum thing. I would redo this with that drum thing because you already have the answer for it. You already have the system set up and see if it works. It gives you an answer. That one was a maximum. So maximum problem, no different. Just go and list all the X, Y combos you found at the corner points. So I think that thing had like four corner points or 5 corner points. So you put all those corner points in here and then find the profits in that case. And the biggest p-value would be your maximum. All right. Who is watching cartoons? Raise your hand if you're watching cartoons. That's okay. That's human. No one's going to admit it. You're not supposed to lie here. Right. The hard part's actually finding that point. So, like, if you unravel it, you have to get that feasible region, which is a huge mess to get to. And this, by the way, this only works for 2 dimensions. Right? You can't draw things. You can draw it in 3 dimensions, but it would be painful.